Okay, hi everyone. Welcome to the IM Tech Meetup, and we can get started. So this is the IM Tech Meetup in October regarding Next.js, and we've got some amazing speakers here today. Just gonna put my headset on. So yeah, today we're going to be having a great talk about Next.js. So let's get started. So the IM Tech Meetup is sponsored by two sponsors. One is kontent.ai and the other one is MNT Digital. So thank you for the sponsors. And just a little bit about me. I am a Ilesh Mistry and the founder and organizer of the IM Tech Meetup. I'm a CMS specialist and a kontent.ai MVP. My contact details are on the right-hand side. And if you want, you can subscribe to my YouTube channel, which will have the recording of all of these sessions. So a little bit about the IM Tech Meetup. It's front-end driven topics, and generally they happen every couple of months. And if you want to know more about meetups or know about the sort of recording or when things are going to happen, then by all means follow me on LinkedIn and Twitter to reach out for more information. Also, if you want to speak at a future meetup or know somebody else who would be a good candidate, then get in touch with me as well. A little bit about the sponsors. So kontent.ai, they build digital experiences without compromise, and they're cloud-native CMS that lets you sort of build websites and applications fast without, basically in any technology that you want. On the right-hand side, you can, register for a kontent.ai 90 days trial, or you can also join their Discord channel, which is full of developers and marketers, and you can obviously ask questions about content as well. Kontent.ai are recruiting. So, if you're interested in switching careers, then use the QR code on the bottom left there. And a little bit about MMT Digital. They're basically a company or an agency that's using technology to build a better future, digital consultancy and trusted delivery partner. So if you want to know a little bit about MMT Digital, then use the QR code on the right-hand side. So I'm checking a lot of QR codes, but they're easier to do. And again, MNT Digital also recruiting, so we've got various locations available and different types of roles. So if you're looking to kind of switch careers, then get in touch. So before we get started, the sessions that we're going to have today, please add your questions in the chat. And at the end of each of those sessions, you should be able to have a little bit of time if you have any questions that you want to ask as well. As you can see already, we are recording the session, so if you have to drop off, and that's all fine. So I can share the recording after the sessions anyway. So you can obviously catch up with them later as well. A big help would be is that if you can be active on social media and use the hashtags and in this case or even the @ symbols for IM Tech Meetup and Ilesh Mistry. Also, if you want to have a chance in winning some swag, which is something that I am wearing at the moment as well, then use that QR code on the right-hand side. I will be, passing on the link throughout the different sessions anyway, so don't worry if you haven't got the link just yet. Because it's Next.js, I have to make sure that we mention the fact in a couple of weeks' time, the Next.js conference is out. all coming out, and there's still time for you to register for that event, and it's super exciting about that. So today's sessions, it's going to be myself. Just going to give you a general introduction to Next.js. So give anybody who's not experienced it or needs a refresher can go into that. Then we've got Ondrej, who's going to be talking about pre-built scripts and why we need them in Next.js. After that, we've got Tom, and he's going to be talking about the on-demand incremental static regeneration. And then after that, we've got Oleksandr on micro frontends with Next.js and Module Federation. And then Shivay at the end, talking about serverless and edge functions in Next.js. So let's get started. So I'm just going to flick over to another presentation. And hopefully you can see that. So hi, everyone. Welcome to my session regarding getting started with Next.js. And just a quick intro on who I am. I am the founder and organizer of I Am Tech Meetup. My name's Ilesh Mistry. I'm a CMS specialist and a kontent.ai MVP. If you need to contact me, you can use the right-hand information, and also you can subscribe to my YouTube channel. So what I'll be covering is a little bit on like what is Next.js, why to use it or why you should use it, how you can get started, and probably a quick demonstration, and then some takeaways for you. So it'll be a quick sort of intro to Next.js. So what is Next.js? So when you go to their website, it's pretty much the React framework for production. They kind of say that it's going to be a best developer experience or really good developer experience, and it allows you to do lots of things like hybrid static rendering and server rendering, TypeScript support, lots of important stuff that developers these days are looking for, like prefetching and things like that. So for me, I would probably sort of like describe it as well in slightly different, or add to that is to say, okay, it's a web development framework and it's created by Vercel. So, that's quite important, is the fact that, the way that it's being created is that it's open sourced. So it's very, it means that if you have any contributions towards it, you have a chance to kind of contribute towards it. And fortunately, a lot of frameworks out there, or front-end frameworks, always considered to be React heavy. So in this case, this is a React framework that gives you building blocks to create websites and applications. And as it's highly connected, or it's built by Vercel, there's a smooth deployment platform with it as well, which is, I think, sometimes the case is you have something that you're using, and sometimes you have to think, okay, which platform do I need to host this on and do my deployments with, etc. So in this case, Next.js and Vercel work really well together. Sometimes I think, like, another way to describe it is that it's a wrapper, like a React. Basically, it's wraps around React, so you've got the benefits of React, but then it bridges the gap for you when you want to kind of display on the browser. A typical React client, normally client side, is you don't get anything apart from once it's actually been rendered. And in this case, Next.js helps you pre-render everything, and then it shows you on the page. So a little bit about pre-rendering, because that's one of the key benefits of Next.js. It's basically, instead of doing everything on the client side, Next.js generates HTML in advance. So there's two forms. One is a static generation, which is pretty much build time. And that is basically, you build the application once, and then you can serve it multiple times or many times via the CDN. It's obviously faster than the server-side rendering, because it's not then requesting every page or every request. Whereas server-side rendering is request time, so you end up requesting it every time, or you end up kind of going to the server to request it every time you need it, and then that can prove slower. So there's two sort of like diagrams there taken from the Next.js website, and you can see the difference between those two in a sense of static generation should be the most sort of used one because it's going to be faster, quicker to the audience. But there are instances where you need to kind of use server-side rendering as well. So one of the reasons, or people will be asking, well, why should I use Next.js? This is obviously from their website, and they basically, like I talked about earlier, they want to be best-in-class developer experience. They want to produce or have the ability where you can do dynamic routing, handle pre-rendering for static and server-side aspects of your development process. Have client-side routing in there as well, and prefetching, lots of other stuff, and even API routes and using sort of serverless functions availability out there. So they have a lot of high sets of commitments that they want to kind of be delivering on, and that's why a lot of people are interested in Next.js. So like I mentioned, it's one of those ones that are most recognized, like highly recognized, widely used in the development community. Big brands have it or using it, like TikTok, Notion, Nintendo. It seems like the go-to for most developers, and obviously it depends on developers' experience, but it seems to be like, because it's such a stable and fast in the market platform, it seems to be like a strong lead out there. It also does a lot of things like image optimization and other things that they've got available. But one of the good things about it as well is that it's obviously because of its pre-rendering stuff, it's better for SEO as your HTML is loaded, preloaded compared to a standard, say, React application. One of the other things I love, using Next.js is the fact that it's got its connectivity with Vercel. So, I've used other things like, say, Netlify, and you still have to kind of connect things up, and it's not that tricky, to be honest. But Vercel sort of like, here it says basically develop, preview, and ship, and that's one of the key sort of requirements. And what it does is that pages that are there using static generation and assets will then they'll be applied to the super fast Vercel Edge network. So I know that we've got one or two talks later on talking about Edge as well. So I'm sure we'll know a little bit more about that as well and the benefits of it. The server-side rendering and API routes, and obviously that sort of way of building is another thing that they do, is they basically allow it to become serverless functions, and that just makes it something that can be grown and used around their audiences. One of the key things I wanted to show was, which I'll show you in a bit when I demo something, is a sneak peek of the preview functionality, which I think is something that I haven't seen on, say, on normal sort of hosting platforms, but it might just be the way that our systems teams set things up as well. And this in particular is a preview functionality during a pull request function, and you can actually see the changes before they actually get merged and deployed, which I think is sometimes really important in case you looking to try and change something, and you can make those changes before it's actually been merged into, say, a particular branch. And the preview URL functionality as well within Vercel allows you to share it to others as well, which could be quite useful, because before you merge a pull request in, it may be good to kind of get some kind of sign off as well. So if I go to the next bit, I'm going to do it like a quick sort of demo, but it'd be more on sort of like the basics of Next.js. So I'm just going to come out of here and bring over Visual Studio Code. Excuse me. So what I'm going to do is just quickly just kick off how we can create a Next.js website. So let's just make sure I'm in the right folder. And some of the sort of, all of this stuff you can get up the Next.js website, but in this case, it's like a normal way that we would create a React app. But in this case, we're creating a Next app. And I just want to talk through some of the stuff that gets added in. So hopefully it won't take too long to run through the process of installation. Cool, so that's done nicely. So yeah, I've just basically gone through the process of creating a Next.js IAM Meetup application. And I just want to quickly talk through some of the stuff that's actually on there. So as you can imagine, you've got your dependency modules within here. Next is heavily sort of dependent on the pages structure. So we'll talk about that in a minute. A public area just for sort of normal standard React app would normally have as well. It's just an area to kind of put in some static information. And then in this case, you've got a styles folder, but majority of the stuff is like here. And then you've got the Next.js config, should you want to do anything additionally to your Next implementation. One of the things I want to kind of mention is that Next heavily, or the Next routing kind of heavily depends on the side of pages section. So, you end up having, relaying or creating pages within the pages folder. So if you have like your routing application to say something like /about us, then you would have a page within here that says about us .js or something. In this case, it's JavaScript, but you can also do this in TypeScript as well. So a lot of the configuration tends to be boiling down, especially when you do create a simple React application, simple Next.js application, is that within the pages section, you would have your folder structure. So for example, if I go and create a new file that says about us, it's not that again, sorry, about us.js, then this will become the URL for you about us. And now if you wanted a section that had subsections within it, then all you really need to do is create a new folder in there. And that would probably be something like company. And then you could probably put about us within there. Just move that into there. And that would just mean that your URL structure would be /company /about us. Majority of the time is quite simple to kind of have like home pages or specific pages that you need to go to that don't need a sort of particular path towards them. So in this case, for example, if you want to go to the home page, it's normally index rather than /. So that's one way of doing it. But for example, if you wanted to go to the company homepage, then all you would need to do is add a new index file within here. And that would allow you to have the company page that you can kind of reach and go to. So that was just a quick sort of, demonstration of a quick Next.js application. What I'm going to do now is flick back and almost do like a flick to a presentation and then flick back off again. So just bear with me. So what I want to do now is really look at the deployment side of things, because creating a Next.js application is quite simple. You can kind of follow the tutorial, which is going to be really useful, and I heavily recommend it. But what I want to do is kind of say, okay, like once you've created an application, And my favorite stack is all of these things here with Next and Tailwind and TypeScript and a headless CMS and a deployment mechanism. What I want to show you is once you've actually created your application, how do you kind of deploy it to Vercel? So again, I'm going to flick over off this and come back to this side. So what I've done is I basically have followed Next as example of using kontent.ai, a blog. So I've just gone through the steps and follow their steps all the way through to kind of add in some content within the CMS. So the CMS is in here. So you'd see some, I've just created some very simple sort of author and blog posts within there. And what I want to do is demo this stuff onto our website, which is not a problem. So if I just go into here and if I've got my local host running, so if I just go back to Visual Studio Code and just flick over to the right. And I did mention this before, but to run is similar to how you would normally run a local environment. So in this case, I'm just going to do yarn dev. And what that will do is obviously launch my connectivity between what I've followed through in setting up a Next.js website that picks up content from kontent.ai. So while that's loading up, hopefully this will work, and I'm praying the demo gods are with me. And just making sure that everything comes through okay there. So with that, that's all great. You've got that all set up. And what I want to kind of be looking at here is how I'm going to be deploying this onto Vercel. So let's flick over to there and go to my project, which is here. If you've not seen the Vercel interface, it's very simple. And I've just got, they've got sort of like separate tiers in the sense of what you can do. And their free tier is called Hobby. And with that, you can play around with as many websites as you want, and you can start like deploying it for personal use as well. So what I'm going to do is look at the interface here. And normally what happens here is that you can connect it up with the Git repository. So in this case, I've got this repository already kind of set up. And all I want to do is kind of connect it up with Vercel. So, you may need to adjust your GitHub permissions just to allow it, because I'm quite like that. I don't want everything to be kind of used by every system that I use. So I kind of specify which repositories will be used here. So, and all you need to do here is click on the import process. And generally, I think what Vercel's really good at is the fact that it knows there's a Next.js website. So most of the stuff here is just going to be following everything you need to have in there, and you don't need to worry about too many things in here. So you can go ahead and hit deploy. And deploy shouldn't take too long. It says that, but it probably might take a few minutes. And I can just open up the building side of things, and I'm hoping it doesn't fail, fingers crossed. It worked fine earlier, as they say. But normally it's going to do everything as you normally would do locally. So it's going to go ahead and install all your packages, and then going to start building your application. So hopefully it's gone through so far okay. And I'm hoping it doesn't take too much longer. But yeah, so basically it will go through all of the processes and looks like there's an error. So there we go. So this is what happens when you have a demo going on, a live demo. It looks like there are some errors here. So I am going to flick over to another example. It's almost like Blue Peter, as people have it in UK, where I had something I prepared earlier. So let's see if this works. Let's go into this one. Let's try deploying this one, and hoping that this might work. If it doesn't, what I'm really trying to show here is the fact that I can go ahead and create a, and I might have to do it as almost a V2 now as this goes along, is the fact that if I've got a website that has some dummy content in there, and say, for example, this Next.js blog, and let's just come in and come out of there and go into that. And go into this particular example of the Learn blog. And just make sure that's running. Okay, so that's great. So that's running. So this is actually just, I just want to go to the dashboard of this and just make sure that we can go and see the website. So this has just gone through the process of adding a particular, repository that I've set up earlier, and we can go and visit that page. So it's just a very basic, setup on here, and not the one I want to show, but it's another version. And what I wanted to really illustrate here, and I'm hoping that this is all connected together again, is the fact that if I basically make a change to this particular item, so let's go to the code and go to, say, the layout area. And let's say I just want to, sorry, it might be good for me to show the actual element here. So for example, it's just a basic website, has 2 links to blogs. So if I click on one of them, you can see there's got a normal blog page in here, and I can go back to the home page. So very simple setup. So if I go back to the code, and let's see if this is on there. Just double check. Yep, back to home. So if I go back into here, the idea is that when I make a change into here and develop a pull request, what that will do is that pull request will basically be added into, say, GitHub. And then when you go into GitHub, before you actually even get the ability to actually merge anything in, what you can do is that the cell will kind of stop and say, hey, like, do you want to preview this before you actually kind of, hit merge? And that's one of the good things about it. And I'm just gonna, sorry. And that's one of the good things about it, is the fact that it will do this kind of process here, which unfortunately the demo gods have not been nice to me today, but it'll basically stop and say, okay, like, you've added something in, go and view this. So you can actually click on a link. And clicking on that link, what that will do is that will basically say, okay, like, what is the state? So if you've made a change, so let's have a look at the code. So say, in this case, I said back to learn Next.js home. And actually in the code, originally, let's just bring that there, it was actually showing up, where's it gone? Here, back to home. So say you made some sort of like changes in your pull request that actually you want to see before you actually merge in the code, say on the development website, then what you can actually do with Vercel is the fact that you can actually click on the link that gets applied here. And what that will do is that will launch a preview of your website with those changes on there. So you can actually physically see those changes before someone actually approves that PR, and then it gets merged in. And I think that's one of the sort of like amazing features that, you hardly sometimes get when you're actually working with, say, something like, Azure or AWS, where you have to kind of like, almost incorporate those bits in, whereas this comes out the box from the cell. And this is like one of the really cool things I think that are out there, especially for sort of like developers out there who want to see, or even if you want something to get approved. This is a really important, and I really apologize that you can't see this actually physically working, but how things go with the demo stuff. But yeah, that's kind of what I wanted to show. I'm going to flick over to the presentation again. and looks like I didn't work out well for me. So I'm going to give you some takeaways. So I think they have like a lot of sort of like, platforms like this. They have awesome documentation. I found that their tutorials and learning material actually, even though I've worked with Next.js, it kind of prompted me some things that I never or couldn't, I didn't really think of. So it's really handy to kind of refresh. It's very easy to get going. I would recommend to subscribe to their newsletter because that's pretty cool, and you just get updated the latest features. Obviously, follow them on Twitter and LinkedIn as well. This deploy, preview, ship stuff was really good. Unfortunately, I couldn't show you how it worked, but please try it out because the preview with the pull request stuff is, I feel, a good, basically a game changer. And then the other few things I would probably say is that sometimes when you're looking for some hosting platforms, you may think, okay, well, what should I consider? Should I go to AWS? Do I go to Azure? Do I go to Netlify? What do I look at? And the style is there for you because you're using Next.js. So I think like sometimes you can avoid kind of going into different directions. And very easy to kind of like start deploying websites. So you don't need to be a systems engineer. You kind of can get going without any problems. And one final thing is obviously, check out the Next.js conference coming in in a few weeks. And that's it really from me. Are there any questions? You can obviously, contact me using the following links as well. Cool. So if there's no questions, I'm going to go and hand over to Ondrej.
Hello, can you hear me?
Yep.
Nice. Okay. Let me figure this out. Can I share?
You should be able to.
Okay, give me a second. Is this the right screen?
Yep, looks like it.
Okay, so you see the presentation, yeah?
Yep.
All right, perfect. Well, thank you, Ilesh, for having me. I'm Ondrej, and today I want to tell you something about pre-built scripts and why we do need them in a Next.js. I'm Ondrej. I'm a developer evangelist at kontent.ai, but that's probably not why I'm here. I'm here because I'm also in charge of our main site, which is built on top of Next.js. We switched from Gatsby, I think a year ago, and hit a lot of roadblocks, during the implementation. And the pre-built scripts is probably one of the biggest topics that we did not know from the start that we needed. But as we were adding features, we recognized the need for those scripts. And I want to show you the implementation that we have that can maybe save you some time. So what are pre-built scripts? Pre-built scripts are something that runs before your Next.js build. So before you do npm run build or npm run dev, whatever. These are some tasks that are running before that actually happens. So it can construct data that you need for the build, which is a key thing, because you usually need these scripts because you need to handle some tasks that you can't handle when the build is actually happening. Yeah. We've stumbled upon I think 5 use cases for these scripts. First of them is URL changes. So when you need to when you're using a headless CMS and you change the URL slug of a content item, then you need to tell Next.js the old URL and the new URL. And you cannot do that during the build when you have the data because it's too late. Yeah, Next.js doesn't support that. You need to provide a list of those ahead of time in the Next.js config. So that's one thing. Another thing is generating models. So we currently have around 180 content types in our implementation. And well, the Next.js side, the whole site, as we use it, uses only strongly typed models. Yeah. So before we actually run the build, we run a script that takes all the data from the CMS and generates a strongly typed models from that. Next thing are A/B tests. So when you're running an A/B test, you typically want to use the Next.js middleware to handle the evaluation, which variant to show to people, right? When there is already a cookie, you display that variant, and when there is no cookie, you need to evaluate. But the thing is, you don't want to do this for every single page on your site. So Next.js actually allows you to define only specific paths for which the middleware should be activated. But how do you know that if you don't know the data, right? So we use the pre-built scripts to actually get all the URLs from the CMS that have active A/B tests running on them. And we use that to feed that to Next.js middleware. And next thing are things like RSS feeds, sitemaps, pretty much the static resources that you have on your site. And regarding the RSS feeds, and other things, I know that the Next.js can do that automatically, but you still need to feed it some data. You still need to configure it. So that's what we do before the actual build. And one of the things that I'll get to in a second was generating site-wide data that are dynamic. Now I'll explain what I mean by that. Typically on a website, you have a layout, right? And in the layout, there are typical things like a logo of your company, name of your company, some copyright links, and these things. And if you have these dynamic, it's pretty inefficient to fetch them on every single page. Yeah. So when we actually switched to Next.js last year, everything looked very nice and we were happy and we loved Next.js until we found out that these little things that you need everywhere on every page, you just can't do that with Next.js. The same thing was for the data that you need in almost every component. With Next.js, you only get one function that gets you data into every page. Yeah. So if you need something in the layout, you need to propagate it via props through multiple components. Yeah. So the component that is drilled down, let's say fifth, sixth level of nesting, it cannot get the data from the CMS on its own because it's not capable of doing the data queries. Of course, it can do it on the front end, but that's not what we want to do. Yeah, we want to have a statically generated site. So the thing is that Gatsby actually did it very well. It had the static queries and those, because whenever you run a build in Gatsby, it takes all the data into its local node storage, and it uses that when it's building the pages. Yeah, so you can get the data from the local node storage anywhere you want. They're not constraining the components anyway, so we got used to it, but we can get any kind of data anywhere. So that's the last point that I had. We actually use the pre-built scripts to generate the company data because we've gone through like 3 rebrandings for the past 2 years. So the next one we go through, everything is now dynamic. Yeah. So what we do is before every build, we download the data from the CMS and we generate a code file. It's typical code file as you would create in TypeScript. And we have it available during the build for all the components and all the pages. Now, when it comes to the implementation of the pre-built scripts, of course, you can use the pre and post hooks. Yeah, if you have a script that is called compress, like in this case, or you have a script that's called build, you can always add just the pre-build or post-build like prefix, and npm will run these automatically. So if you want to run just a simple script, simple node script, this is an easy way to do that. But as I mentioned, we already have 5 use cases where we need it. So the line that you see here would be quite long, and that's just the maintenance hell when you need to change something. So this is good for a single script or one-time usage. Of course, you can still use the pre-built name of the script to run this automatically, but the right side of the equation was just too complicated. And of course, when your website is built with TypeScript, you want to use TypeScript also for your scripts. Yeah, not just a simple JavaScript. In majority of the scripts, we also need data fetching. So we need the SDK or other tools that that the systems that you use need. And we also wanted environment variables, which was also not easy to do with the standard scripts. Especially when you have multiple environments in Next.js. Next.js handles the environments a little bit differently than what we are used to. So we needed to kind of align that with how we use it on the website. And we also needed to have some kind of control over the execution. So we needed to know which scripts will be, the order of running, because some scripts need the previous scripts to actually finish. So it wasn't that easy to create. So in the end, we came up with something that we call runner. You see here that there is a pre-built script that is running TS node and goes into scripts/runner.ts. The pre-built is automatically called, so we are actually using the hook, and we are using TS node so that we can use TypeScript. And this way, you can use pretty much any code file that you have in your implementation. So we are using strongly typed models. We are using delivery client from the kontent.ai SDK, and it all works quite nice. So when we're talking about the actual implementation, I'm just going to take you through bits and pieces of the code. It's nothing complicated, and if there are any questions, then I can answer them later. I can also give you a link to, or Ilesh, maybe you can put a link to the code in the chat. It's in the blog post on our site, so that people can look at that too. So there are a few tasks that you need to do in order to run the scripts from something that I like to call parent script. Yeah, that's the runner as you're looking at it. First thing you need to handle are the environment variables. So as I mentioned, Next.js actually has a bit of a different naming and different handling of the environment variables. So the only thing you need to do is just import load env config from Next environment and run load env config with this parameter. And this will actually ensure that the process now has all the environment variables for the environment that you're in. Very simple, and it works 100%. It's in the documentation, very, very well done, I have to say. So you don't need to do any kind of a .env .config and all those other things that we are used to. You only need this one call. Yeah. Then of course, the scripts as we run them, they usually have some kind of output. Yeah. Be it a JSON file, be it a TypeScript file, as I mentioned, the code files. Be it anything else. So we are actually creating a static folder, a folder literally called static, where we are putting the output of those scripts. Of course, the script can decide to put it anywhere else. This is just something that we like to have for the JSON files that are generated. Yeah, we don't like to keep them in the root. And the next thing is to actually find all scripts in a subfolder. So we are using a folder that's source/scripts/prebuilt, that we have everything in a single place. And when a new developer comes on the project, they exactly know what they are dealing with. Yeah, these are the pre-built scripts. They are run during or before the build. So that's what we do here. We are reading the directory. You see that the directory is called pre-build. And we are filtering the files, only the files that end with .ts. Of course, there shouldn't be any other files. This is just a security precaution. And then we sort them. We are sorting them because we want to have an alphabetical order. This is only because we have one script there that needs the first one that is called, I think, company data or something like that. So it's pretty up the chain. There was really no other reason for the sorting. This should probably have some more logic in there, but we didn't need to do that yet. We would just probably, if there is a script that starts with Z and needs to be run in the first, we would just probably put a prefix before that and have it run as the first one. So you then create a list of all the files that are in the folder. And this is where it gets interesting. The scripts as they exist, they need to follow a united pattern. Yeah, that's the first line that you see here. So in order to run the script and execute it automatically with the parent script, they all need to have a default export, and the default export has to be function execute with these params. Yeah. Again, the only reason is that so that we can execute it automatically from the parent script. They are async, obviously, because a lot of those scripts, as I mentioned, are fetching data, so they need to, or we need to wait for them to finish. Yeah. The parameters, as you see here, the iScript params, was just a wild guess when we started creating these scripts, because we didn't know what all parameters we will actually need for the scripts. The only thing we ever needed, though, was the environment variables object. And unfortunately, it's really hard to get a proper type of it. So right now we have only env that is any. Yeah. But the good thing is that all the scripts can be strictly typed and use the params that is iScript params. So as you create the pre-built scripts, they all need to have this signature. Of course, they can have other methods. They can have helper methods, whatever they need for them to work. But this is the main function that will then make sure the functionality is there. And the final piece of code is this one, where we actually go through every single file. And what we do is, this is like probably the most complicated line of the script. What we do here is we actually await import of the file. Yeah, so we await import of every single file that is in the array that we fetched. And when we import it, it always has a default export, right? But the thing is, we cannot call it default because it's a reserved name in or keyword in JavaScript. So what we do is we know that the default is there, but we rename it to default func, like a default function. Yeah. The second curly brackets here are not necessary. This is only a TypeScript definition that says there has to be a function that accepts iScript params and returns void. Yeah, because we don't expect any output from that. But this is really the only important thing to know, that you cannot call it default. You have to rename it this way. And then what we do is just await the default function and provide it the environment variables. That's the only thing we do. Of course, sometimes there are errors, so we need to do some error handling. So that's why there is a try catch with the script runner. And it's good to always like output the error and say like which pre-built script it was, because we have 5 and it was really hard from the error to figure out which script it is. So yeah, what we do is just identify the file and then output the error. And yeah, that's pretty much everything that you need to do. So this is how it looks like when you run it. If you want, I can show you that in Visual Studio Code as well. I'm actually showing the whole screen, right? So I can actually do that. Let me check. Can you see Visual Studio? Perfect. All right, so that you know that this is not just a picture in a PowerPoint presentation, yeah? I hope this is the right project. Oh, no, it isn't. Okay, let me check. AI. Yeah, that would be it. Okay, so when we give npm run rebuild, this might take a while, but there you go. So it's running these pre-built scripts to generate the company info, redirects, RSS. Usually it's quicker, but must be the teams. And the sitemap, yeah, and everything was generated, and we are good to go. So this is kind of how you generate everything. And as I mentioned before, the static code file that we generate for every single build, and we use it on a lot of places. This is how it actually looks like. So this is what we generate. You see, it's a simple code file that contains the company info model. This is actually a generated model from the headless CMS, and it contains some system data, but these are the important things: the elements, name. This is the name of the company. We generate the logo. This is the name of the file. There's also URL in the structure. We generate things like a URL of the website and so on. So we are actually able to use this in the website as any other code file. Yeah, we generated before the build, and this is actually how we use it. So when there is a link in our implementation, we just do companyinfo.elements.facebook.url.value and have everything there, even though it's dynamic because we build it before the build using a script. All right, and that's everything from me. Hope you liked it. I think, Ilesh, you did share the link, right? So in the blog post, you will find the whole source code. Happy if you find it useful. If there's anything I can help you with, then definitely let me know. This is a QR code for my Twitter. And if you're into Next.js, I'm also delivering a workshop tomorrow in React Advanced as part of the React Advanced conference, which is about a crash course into multilingual websites in Next.js. So if you wanna take a look at that, definitely register at thereactadvanced.com.
Nice. Thanks, Ondrej. Any questions for Ondrej? I guess while people are thinking, I've got one. For me, it's a case of like, what were the reasons you kind of decided to move away from Gatsby? And even though you had some difficulties, like you mentioned, do you feel that you made the right choice?
That's a very good question, and I think we can spend another hour talking about that. The thing with Gatsby was the developer experience wasn't that good, and the editor experience was a total catastrophe. We were waiting 25 minutes for builds, while now with Next.js we have 1.5 minutes. That was the biggest thing. With Next.js, we pretty much don't care about how long the builds are because they are pretty much instant. Another big problem was were editor previews. Now with Next.js, we have that for free and it's server-side rendered. So this approach that Next.js has really removed multiple deal breakers that we have with Gatsby, and yeah, those were, I think, the biggest reasons. The longer that we use Next.js, the longer I'm convinced that it's the best Jamstack framework for large sites. While Gatsby is probably the best if you have a smaller site and you really want to get something up and running quickly. With Next.js, there is a lot more heavy lifting in the beginning, I would say.
Okay, great. Yeah, thanks. Any other questions from anybody? If not, thank you, Ondrej. Really good presentation. Tom, you're next. Just let us know when you're ready as well.
Yeah, can you hear me all right?
Yeah, perfect.
Super. Okay, right. Let me sort out the screen share. How is that looking? Can you see what looks like a presentation? Yeah, good.
Looks great.
Right. So, hello everyone. First of all, a little bit about me and who I work for. My name is Tom Marshall. I'm head of technology at Cyan. Cyan are a UK-based technology agency. We are a team of 50 strategists, designers, and engineers. We've been working with React for 5 and a bit years now, and probably Next.js for nearly 3 of those. And there is a photo of what I used to look like when I used to get a haircut. So, talk today is an introduction to Next.js on-demand incremental static regeneration, which is obviously a bit wordy. So you may hear me say ISR here and there. If you hear ISR, that just means incremental static regeneration. So I want to give you sort of a bit of an idea of what to expect from the next 20 minutes. I think we're going to start off with a recap of the Next.js rendering models. Ilesh touched on that a little bit right at the top, but we'll go into it again. I think it's important, the reason to do that is it's important to understand the existing rendering models, to understand what on-demand incremental static regeneration is bringing to the table. And then we're going to have a look at what on-demand ISR is, how it works, and then ultimately kind of the problems that it's solving. So jumping straight in with the Next.js rendering models. Historically, we've kind of had a choice of 3 here. And I think something that's worth stressing to anybody who's new to Next.js is that although you've got these different rendering models, you don't choose one of these for your whole site. You are able to opt in and out of these per route or per sort of URL pattern, which is something that's pretty powerful and flexible, and just something to bear in mind as we go through some of these and I'm talking about the trade-offs and benefits. You've got to remember that potentially it's just one area of the site that's doing this rather than the whole site as a whole. Of course, you can do the whole site all in with one of these, but yeah, you can combine them together. So yeah, we've got static generation, server-side, and incremental static regen to quickly touch upon in terms of what they are and what they're good for. So starting first off with static generation or kind of pre-rendering, I think the big distinction here is this split between build time and request time. So for a static pre-rendered site, what we are doing is we are building all of that, all of the pages out for the site at build time during our CI pipeline. So if content changes in our external sources or if our code is updated, then the CI pipeline kicks off a build. We build out all of the pages for the site, and then we publish that up to static hosting, potentially a CDN. And then when users are requesting the pages of our site, they're just getting those static pre-built pages. There's no kind of compute resource here at that point. So how does that work in Next.js? Well, there's 2 functions that we need to use if we want to make use of that: get static props and also potentially get static paths. So looking at get static props first, which is the second function on the list here. Effectively, that is responsible for fetching all of the data needed to render the page and then passing that through to the page component, which in this case is post up here. You see sort of post as a param there and down here, passing that through as props. So this is all concerned with kind of an individual post page, posts 1 sort of in this example. We then move on to get static paths, and depending on the routes, we may or may not have to implement this. So if we think of something like the posts index /posts, there is only one version of that page, and at which point we wouldn't need to implement get static paths at all. If, however, we talk about kind of the /posts slug page, so the page for a specific post, which is what we're looking at here, we need to implement get static paths so that we can tell Next.js at build time all of the different paths that it's going to need to render, all of the posts that are present on the site. And you can see kind of a pseudocode version of, straight from the Next docs actually, of fetching that post data, getting the parameters out of it that go into the URL slugs, and then passing that out to get static paths so that Next.js knows how to build that out. So what is this good for? So as Ondrej kind of touched on with his answer and response then, smaller sites that don't require dynamic or personalized content, this is kind of a really clear win because sites like this are super cheap and performant. But if you get into sort of larger sites, you can get into trouble with lengthier build times. If we think of a site with sort of hundreds or thousands of pages, we're having to issue a complete rebuild of all of those every time any page within that changes. So if we've got content that's being changed regularly, you can end up with sort of quite long delays before we're seeing that sort of a pipeline backlog or something like that, before we're seeing those content changes published through to the site. So that brings us on to the second option, which is server-side rendering. So server-side rendering, the big shift here is moving where the pages are rendered from the build time over to the request time. So we still have a Git repository that when we're making changes to our code, it's still going to a CI pipeline and we are still building and deploying an application. But what we are not doing there is building out all of the pages for our site during build time. That's actually happening. The build of the pages happens at request time. So when a user requests a specific page, there might still be a CDN here, there may not, but ultimately they're ending up at a compute resource on a backend server that's then talking to external sources of content to pull in all the data it needs, render that HTML, and ultimately return that to the user. So how does that work in Next.js? Well, effectively, we've got pretty much a straight swap from get static props to get server-side props, which you can see over here. And this function is doing exactly the same role. It's fetching the data needed to render the page and then passing that through to the page component as props. The big difference here being that that's happening at request time, not at the build time. And obviously, although it's not shown here, we get access to certain stuff that we wouldn't have in get static props, things like the actual request object, potentially the session, which obviously opens the doors to being able to do certain things that you couldn't do statically. So compared to sort of static rendering, what's this good for? Well, we can do dynamic and personalized content here. As I just mentioned, we know who you are as you make that request, so we can personalize that response before we send it back down. We can, for sites or routes with larger page volumes, so hundreds or thousands of pages, we don't have to build all of that out during our deployment. Whether it's 2 or whether it's 2,000 pages, it's going to take exactly the same amount of time because the actual page render is happening at request time, i.e. later down, so we get those faster builds. And then ultimately the time critical data. So an example, like sort of e-commerce examples here, but if you imagine you've got a static site that's taking minutes to a lot of minutes to deploy, and occasionally site, depending on sort of the nature of the site, you might have content that's extremely time critical, things like pricing or stock availability. You don't want customers waiting 20 minutes to get an update on the fact that something's now out of stock and getting frustrated as they're getting through to cart. So server-side rendering is something that we've needed in the past there to deal with that kind of time-critical data. In terms of what it's not good for, or kind of the downsides of it, obviously we've got an additional hosting complexity and overheads there with our application server, which is going to incur additional costs. And then, yeah, there's a performance aspect here. Some of that can be mitigated with other forms of caching, but that brings its own complexity. And I know Shivay later is going to be talking to us about the edge, which is also relevant here. But yeah, generally, we generally think of static rendered content as being better for performance. So that brings us on to a third option. So for the longest time, well, for a fairly long time, we've kind of had just those two. And then Next introduced in 9.4, which I think was mid-2020, they introduced the idea of incremental static regeneration. And effectively, ISR is an extension of the static model with get static props and get static paths that we saw on that static example that I showed first. The key thing with ISR is that we get to create and update static pages after we've built the site. So we don't have to do the entire site all in one go at build time. We can continue to do it later, which is the incremental aspect of that. And that makes it an option for larger sites, as potentially we don't have those huge build times anymore. But we can, and with that, we can still get all of the benefits, the performance and the resilience that we get from a static architecture. So how does that work? So there's effectively 3 elements that Next introduced on top of static regeneration to bring this to life. The first thing they pulled in was this idea of fallback, which is defined as the get static paths. So that really allows us to defer the first render to request time instead of build time. So no longer do we have to build out all of our pages. We can build out potentially none, or just a subset. We could do the 100 most recent or the 50 most popular if that's easy to determine it. We don't have, the key thing is that with fallback, we don't have to build out all of the pages anymore because we can build them out at request time as a fallback. The second element here is revalidate, and that's a prop that gets passed into get static. It's an attribute that's part of the return object from get static props. And with that, we really just declare sort of an integer in seconds for how long it will be until we attempt to revalidate the page. So kind of as the docs say here, we attempt to regenerate the page when a request comes in at most every 10 seconds. And The key thing around that is we no longer need to issue a rebuild of the site when content changes, because we're now able to specify this revalidate duration, and then after our 10-second expiries elapsed, we will go back to our sources of content to rebuild that without having to rebuild the whole site like we would have done in a purely static model. And then the final element here is this stale while revalidate, which really that's just the name of kind of the caching approach that ISR takes, and that's probably easy. Well, it's definitely more easily explained with a diagram. So if we, in this situation, we've got a page that's going to be requested by 2 users, and it is already stale. It is older than 10 seconds old, given that revalidate duration from the previous slide. So user 1 requests that page, and it's stale. But instead of the user waiting for us to rebuild that page, which may take a couple of seconds or potentially even longer than that, stale while revalidate responds with the stale content from the cache. But what then happens is it triggers a rebuild of that page because it was stale in the background. And then when that's complete, the page cache is updated so that when user 2 comes along and asks for exactly the same page, it gets the updated content that user 1 triggered. And that is a really powerful mechanism, effectively. It unlocks a lot of performance. Like, you'll hear people say that Next.js is a really fast application framework. A lot of that comes out of this stale whilst revalidate caching model from ISR. So what does this mean this is good for? So effectively it unlocks the performance and resilience benefits of static for sites or sections of the site with larger page volumes that otherwise previously we'd have had to have done with server-side rendering. But we've still got some challenges here. Personalized content or dynamic content is still a challenge. We have no concept of the request or the session to personalize a response. And also that time critical data, obviously we still have a caching duration here. So for that e-commerce example that I mentioned earlier of pricing and availability, there's still going to be a delay until our users are seeing the updated state reflected. So that's kind of a somewhat quick recap of what we had with the rendering models before and traditional time-based incremental static regeneration. What is on-demand ISR and how does that work? So on-demand ISR was something that Next introduced in 12.1 as a beta and then 12.2 stable. It's using that same stale while revalidate caching model, but it's got a different caching validation strategy to the time-based duration that we've just gone through there. Instead, we've got this revalidate function that allows us to programmatically define when a certain page should be revalidated, when it should be rebuilt. So how does that work? So obviously in these scenarios, we've always got an external source of content or data, and that needs to issue some sort of notification, typically a webhook, when a change has occurred. And that we need our Next.js app to have sort of an incoming API route to handle that incoming webhook and implement the revalidation logic. So that flow sort of loosely goes as the content editor publishes a change in the headless CMS, in this case kontent.ai. That issues a webhook notification to API revalidate. Next.js, the first thing it does is obviously verify the validity of the incoming webhook. It then identifies, based on the body of the request object that came from the webhook, which content, which page needs to be revalidated. It then calls revalidate with that page path. And then this down here is kind of where get static props kicks in. We go straight back to fetch the content, bring it back and re-render the page in exactly the same way that we otherwise would have done with get static props normally. So in terms of kind of the pseudo code for how that might look, this is our API revalidate API endpoint. So we've got a default function as our handler being exported here. First thing we're doing is verifying the validity of the request to make sure it's trusted. We're then identifying the path that we need to revalidate, e.g. blog foo post. We're then revalidating that, calling revalidate on that page, which is the on-demand function call that we've now been given. we're then returning success or catching to expose an error. Obviously, I haven't, for sort of brevity, I haven't given you the full example here with how we validate a request or how we get the path to revalidate. But if you are interested in getting hands-on with it or having a look at a more in detail example, there's a repo on my GitHub which you can clone and spin up for yourself that uses kontent.ai's webhooks to revalidate pages via the API endpoint using on-demand ISR as exactly we've just talked through. And the README takes you through sort of the setup end-to-end on that. And if you haven't had a chance to scan the QR code or copy the link, I will share the links after. So now that we know what on-demand ISR is and how it works, what problems does that solve? So if we think about our time-critical data again, our pricing and stock availability for example, on a product page, that's an issue for time-based ISR, because no matter what the duration, unless we set a very, very short duration on that, we're still going to be serving that with a delay in terms of its accuracy. So to date, we've either had to pull that data in on the client side, which obviously brings with it its own complexity, loading spinners, and all of those sorts of things, or we've had to use server-side rendering there, at which point we typically are going to take the performance hit, or we're just going to move the caching problem elsewhere. What our on-demand ISR allows us to do is pre-render the data on the server side without the need for that client-side render or get server-side props. Another example of a challenge that traditional ISR faces, if we think about long-tail content, so in this case, we imagine kind of a large popular news site with thousands of articles dating back over the years. The vast majority of the traffic is going to be focused on the more recent articles there. But then we've got this long tail of older articles that rarely change and probably rarely requested. So what do we do about our revalidate duration for this? We could set it to long for a few hours, but obviously that's not going to work because our new articles that are published today, they might be updating multiple times an hour and there's lots of people coming to them and looking, and we need to be timely with that content. So typically what's going to happen there is we're going to set, if we're using ISR, we're going to set a short revalidation, a few minutes, maybe even a few seconds. But what that then means is for this long tail of content that's rarely requested and even more rarely changes, if anyone does come across one of those, we kind of got this unnecessary render cycle where we will render these back out with exactly the same content that they've always had. Which is definitely the right side of that trade-off to be on, but ultimately it's upping our resource consumption and ultimately our costs, right? So with on-demand ISR, that allows us to invalidate the cache more efficiently. We can update newer articles in near real time, and older articles, we'd only re-render those if a content change was published. Otherwise, they just go on with this kind of somewhat infinite cache duration to the next deploy. So yeah, as I said, on demand, it allows us to invalidate the cache more efficiently. So is on demand a replacement for traditional time-based ISR? Like, is this the holy grail of caching where we get to cache for an infinite duration and then we only revalidate the caches when content changes? In short, no. Sorry to kind of burst the bubble on that. I mean, at least the caveat on this is that not practically for most real-world sites. So if we use our news article again, let's work under the assumption that we've gone all in on on-demand ISR and we've got it site-wide. A content editor, let's say a content editor updates an article in the CMS. So our on-demand ISR logic is notified of that change via webhook and it needs to revalidate the immediate article page. No problem. But actually, we've got an articles index that features some of the articles. So if that article is featured on the first page of the article index, okay, we actually need to re-render that as well. Then we've allowed our content editors to merchandise articles onto the homepage as well. So we'll need to check if it's currently on the homepage, and potentially we'll have to call revalidate against home as well if it is. And then we've got categories for our articles, and they've got an index. So we're going to need to go to each of the categories for our article and work out if it's present there and re-render those. And then we've got an author. That bio page also covers it's got a list of the articles that the author's published. And the problem doesn't really stop there. It also goes the other way as well. So our article page has probably got the author's name, maybe a short bio on it, and the category name. If an author item changes in our CMS, or if a category item changes, we need to be issuing updates to all of the articles as well. So assuming a site of any kind of real world complexity, the logic to keep the entire site in sync through on-demand ISR alone is just undesirably complex to implement. I imagine would be even worse to maintain. So whilst it might be practical, impractical to use on-demand ISR instead of traditional time-based ISR, Next does allow us to use them together. So effectively, under that model, we have our on-demand ISR revalidate the critical pages only. So in our article example, that might be the article itself, potentially the article index and just the home. And then we'd have time-based revalidation sat there with a revalidate duration, effectively acting as like a sweeper, doing kind of an eventual consistency thing, acting as a backup to cover all of the other occurrences of content. And that way we get the benefits of on-demand ISR. We've got that potentially time-critical data validated in real time. As product and pricing is changed, we can be updating that product page as that happens. But we can also set longer revalidate durations, knowing that the critical paths are covered and will be eventually resolved. And we can do all of that without kind of incurring that additional revalidation logic complexity that we otherwise would have done had we just tried to do it with on-demand itself in isolation. So what are the key takeaways here? I think, first of all, Next.js's flexible rendering approach is awesome. We've covered quite a lot of different scenarios and different rendering methods there, and all of that is composable together so that we can use kind of the right tool for the job for different areas of the site. I think second, on-demand ISR is a solution to the time-critical and long-tail content challenges that traditional ISR has faced in the past, and it's just bringing kind of it's further growing that percentage of our site that we can push away from server-side rendering and get into that pre-rendered performant world. And then finally, I think on-demand ISR is, at the moment at least, not a practical replacement for time-based ISR on any sites of real-world scale or complexity. So if you're interested in learning more about on-demand ISR, I think probably the first place to have a look at is the Next.js docs. As Ilesh touched on earlier at the top of the call, they are excellent. And there's a link directly through to the incremental static regeneration page there. I also wrote a blog post on this topic if you prefer to consume your content in written form, and that's available there. And yeah, there's the same link again to that demo project if you want to get hands-on with a real-world example that uses on-demand ISR end-to-end. So yeah, I hope that was interesting, maybe even enlightening, perhaps. Thank you very much for listening, and thank you to Ilesh for having me here to speak.
That's great, Tom. Thank you. Are there any questions for Tom? None in the chat, but please shout out if there's a question. Don't know, we can't hear you, Oleksandr.
Can you hear me?
Yeah, we can now, yes.
Yeah, nice. I have a few questions. So first on question. First of all, thank you for your presentation. It was amazing. And but the first question is regarding server side. So you said it's better to use site static generation. If it's not possible, use incremental site static generation. But for example, for such cases when you have a private roles in your application, like user profile, and then when you edit your profile, you need to update the fields as well. So, and you have thousands of users in your database. So for this case, I think it's quite impossible to use incremental site generation, but for private roles related to the user, right, information. So it's better to use the server side.
Yeah, absolutely. If you're doing dynamic stuff, yes, ISR still has no concept of request or session to be able to personalize any of that. But Vercel themselves actually still use, so the Vercel hosting application that Ilesh screen shared earlier, that is using ISR. But what they effectively do is they render a sort of a static shell of their dashboard down. And that's kind of the reason for doing that is they get that kind of time to first byte punch of the static frame coming in. And then they use client-side rendering with SWR to then pull in the dynamic aspects of it, which obviously is just an alternative to just doing that on the server. But yeah, there are options where you can still use get static props even when you've got complete sort of personalization of page content going on, and Vercel themselves actually do it.
And final question, thank you. Final question from my side. It's I saw this funny image when the people start going away from the server side and start using the client-side rendering, then they start going back to this concept, right? A bit modern approach, using the bit modern approach. But anyway, like I understand that server-side rendering, Next.js can bring a lot of performance optimization, right? Like, but for example, if I would say you don't have almost any public roles in your application, everything is hidden by the authorization, so all private roles. Does it make sense to use SSR, or it's better to use Jamstack? So from your perspective, like an expert in the Next.js.
Yeah, I mean, your mileage is gonna vary on that based on your application. I mean, I can certainly see the case that if everything that you are doing is behind a login wall and it's all personalized content at that point, that server side might still be the simpler rendering model to go with. As I said, sort of in the response to the last one, Vercel actually kind of naturally, as part of their pitch, right, going all in on it, they do drink the Kool-Aid of get static props for absolutely everything, and then they are doing client-side hydration to pull in the dynamic stuff on the other side. And they maintain that gives them a performance edge with that kind of time to first byte stuff. But yes, I mean, I certainly don't think necessarily one is universally better than the other. It's what makes sense for your particular application, and also what are you happy to maintain from a rendering model. There's obviously a little bit more to think about if you're doing that kind of frame render and then you're pulling stuff in on the client side compared to a simpler server side model. And then obviously we've got the stuff coming on Edge as well, which is doing even more for performance of server side rendered things, which I think we're going to hear a little bit more about in a bit.
Nice. So I think one of the benefits, but one of the problem actually, it might be a bit cognitive load when you should manage client-side rendering and server-side for this case, but it's not a huge problem. But another important stuff that I guess you also need to maintain your Node.js application and scale it as well. Depends on the load, right? So this is also kind of thing that we need to pay attention on. Do we need it currently or not? So I'm right.
Yeah, absolutely. Yeah. Like obviously, if you're pushing more back onto the server again, you're back in that world of greater sort of maintenance overhead, hosting costs, those types of things. But again, depending on where you are deploying, if you're on Vercel or Netlify or some of these other kind of Jamstack PaaS platforms, they can abstract a lot of that away. It's really just then a case of the costs.
Nice, thank you.
Okay, brilliant. If there are no further questions for Tom, thank you, Tom, and thank you for the questions. Oleksandr, it's your turn, I think, as well. So the stage is yours. And mute again, I think. Yeah.
Yes, can you see my screen?
Yep.
Nice. So first of all, I would like to say thank you for having me today, Ilesh. And yeah, I would like to introduce myself. My name is Oleksandr. I'm a senior front-end engineer at Beamery. Beamery is one of the fastest growing startup in UK in HR sector. It's kind of talent lifecycle management system. So if you would like to know more about it, you can visit beamery.com website. Few words about me. I have 9 years in engineering area, and yeah, mostly working with the Jamstack and also Next. Also, I would like to share a bit about my hobby. I like cycling, I like traveling as well. And the most important fact that last 4 years, I was building micro frontends for many organizations using the different approaches. And today I'm going to talk about the micro frontends with Next.js and Module Federation. But before we go to the exact solution, I would like to share a bit more context about the micro frontend for the audience who never heard about it. So basically, micro frontend architecture, a design approach which your web application decomposes into the smaller parts. We can call them micro apps. For example, you have some web page. On this web page, you have 2 rows, shop and checkout. And these 2 rows can be individual, semi-independent applications owned by the different team. And it's actually inspired by the name of the microservices. So the same approach, like you can split your API by the different services, the same with the front end. And such a concept provides a lot of benefits for organizations. Independent development, when teams are more focused on their subject areas, have a clear responsibility. Independent deployment that allows teams to be more autonomous. They are not depending on the other teams. If they would like to deploy some changes to production, they're just going to do it. For sure, shorter delivery cycle and incremental upgrades. So because we have a smaller applications, we will have faster builds, tests, and it's much easier to add new functionality and do bug fix in the smaller application. Moreover, it reduces complexity because if you're working with a smaller application, you will have a less cognitive load. It will be much easier to understand, and it will be a huge benefit for onboarding process as well. And another benefit is isolating errors. So as you know, usual in your application, you create some error boundary that handles some global errors. But in this case, you can isolate the error in specific application, in specific widget, in specific route, and catch this while the rest of the application will still running and work. So maybe some part of the application will not work, but the rest of the application will work, which is pretty nice. And I can add another benefits related to the error handling is more granular monitoring and alerting. So you can catch this error in specific micro application, and this application definitely should be owned by a dedicated team. And you can set alert to the dedicated team that will going to fix your bug, which is cool. Yeah, and usually instead of trying to understand on which side is the problem, it will be automatically handled by the specific team. But I want you to understand and pay your attention that microservices and micro frontends not completely the same. So for sure in development, they are very similar. Different repositories, CI/CD process quite similar with independent build and deployment. And it can be different teams as well on some micro applications. But in runtime, they're not similar at all because in microservices, you have some separate server running on the different port, running on the different process, different environment. But on the web page, all your micro frontend application running on the same environment and have a lot of global dependencies, such as general event loop where you're executing your JavaScript, shared document object model with events, navigation, local storage, session storage, all of this stuff. And it's okay. You should accept it that, okay, we would like to have some semi-independent micro frontends, but we shouldn't isolate them completely because if we do, we can have a lot of risk. So basically, right now, many organizations trying to implement micro frontend architecture, and there are many risks to do it wrong. And as you can see on the screen, there are many mistakes while architecting micro frontends approach. For example, poor code sharing methods. When you have a lot of duplication in your micro applications, which lead to the slow build performance and bad web performance. Divided our micro frontends to finally. So when you have so many couplet maker frontends that shouldn't necessarily be split too finely. It's difficult to track sharded components. It's harder to do updates and tests because you need to, for example, if you would like to deploy some feature, you need to update instead of the one micro application, you need to update 5 or 6, which is pretty difficult and slow down the development cycle. Overcomplicated communication between micro frontends. So people try to use some event bus, some other technique to communicate, but it also may lead to big cognitive load and difficult to support because it's much easier to have a good component composition and use the same concept like context path in React, for example. Problems with global dependencies, and it's one of the major problems when people load the same global libraries again and again, like have duplication runtime, which leads to the very bad web performance. And another mistake, multi-framework support. Sometimes people try to implement micro frontends to support Angular at the same time in the same application, React, and I don't know, Vue or some other library-based applications. And it's actually provide a lot of problems to the hiring and to the business because it's difficult to find the person who can work with Angular, can work with React as well. And another thing is because you have a lot of different libraries at that time, like Angular and React, for sure it will decrease your web performance. And it will be difficult to reuse global, like custom shared libraries as well. For example, you have some design system in your project and it's based on React. But in this case, you need to use some web components or have two-version design system library, something like this. So yeah. And another a point why all such problems happen, it's also because there is not a lot of information, not a lot of examples that followed by the industry. But let's take a look on the something modern, something popular that we can follow and get many benefits. So for example, one of the popular option is model Next.js monolith application in mono repository. So what it is actually, it's our usual Next.js application, which is inside some mono repository. It can be powered by NX or turborepo. And there are a lot of benefits in such approach. So you can split your Next.js application by the different modules, like by domains or by some major features, depending on your organization. And you will have good independent development experience, low level of complexity. Also, you can add to this NX or turborepo mono repository some shared libraries and reuse it. And it will increase some team collaboration as well. And the more important that you have still Sync React app. And it's usual for you to use some context path communication between components, and it will be a good web performance. And in most cases, you don't need to go further. You don't need to have more benefits because your team may be small or you don't have a huge project. Maybe it's enough for you. But if not, there are a lot of problems because you build each time your monolith application. So no independent builds, slow build process as well, because if you build entire Next.js application and no independent deployment. So each time you should deploy the same monolith application, the same statics to your environment. And for sure, not such a autonomous teams, not such a freedom, right? And is there a solution that we can still have super fast monolith at runtime, but distributed decoupled frontends for the development and delivery, like draw some line in between of two post approach, like a monolith, modern monolith, and a micro. And here we go, beta with Module Federation plugin. So it's a new killer feature in Webpack 5 that allows you to point modules from another Webpack assembly that is tied to different host. What does it mean? So basically, like you do code splitting your application, like dynamic import, but your dynamic import will load a module from the same Webpack project. But using Module Federation, you can load it from the different Webpack project, and it can be on the different host, on the different CIDN even. And I would like to pay attention a bit on the architecture of Module Federation. So basically, once you add Module Federation to your Webpack project, your application becomes a container. It can expose modules and consume modules. And it will actually create separate builds if you expose something, right? And we call it containers. But the host is the entry point of the website. So it's also kind of container, kind of application, which is the entry point, like a first script that you load on the website. And it's cool because it's exactly what we need. We need independent builds and load them in runtime. If you go a bit closer, there's few aspects that I would like to pay your attention. It's export modules and shared modules. So like I said, there is a problem like a frontend when you load the same libraries, global libraries again and again. And Module Federation provided an amazing solution. So each time when container, your micro application need to consume some modules in runtime, it will first of all go to the share scope, check is it module already loaded? If not, it will load it and put to share scope. If it's a library, if it's a shared libraries, it will do the same, but also it will check the version. And it's a huge benefit because usually it's difficult to update the version of the library globally. But in this case, you can have two versions of some library, for example, Lodash or Lambda. You can have two versions to measure different versions at runtime and granularly update your application to the latest one. So yeah, separate builds, loading in runtime from the different remote, shared dependency solution, everything from scratch, from out of the box, from Module Federation, which is cool. And another important part of it is community. Many companies using Module Federation, mostly on the client side rendering, like companies like Netflix, Microsoft, Amazon, and many other big names, which provide huge community, which is important when you have some issues and you need some help. You can go to Stack Overflow, you can go to documentation, you could go to the issues, which is cool. And this Module Federation plugin, it's a bulletproof solution and it's working amazing on the client side rendering. But what about the server side rendering? We are talking about the Next.js, right? And yeah, it's exactly what I would like to talk about, that it already support client-side rendering, whatever you will import and export, like React, Angular, whatever you want. The same with Next.js client-side rendering. But with the server side, creator of the Module Federation, Doug Jackson, he created another plugin, which he called Next.js SSR. And it's a private one, so we should pay some money to be able to install it. I think that is why it's not popular right now. But after a couple months, he decided with his Module Federation team to release SSR and make it open source and upload to the NPM. So right now they're working on the beta version, which is cool. But I had the chance to have this private version on the server-side rendering plugin. So basically it works the same like on the client side, but load all the needed chunk on the server side as well. And yeah, this is a way that I'm talking about how we can implement our micro frontends in Next.js application. And if we go to the real example, so on this diagram, you can see federated Next.js application. So it's our usual Next.js application that split it by three projects, three micro front-end project. And this project owned by the different team, a lot of benefits from micro frontend, but it's actually, again, it's a monolith at runtime. It's a single React tree. And each container, each application provides some modules and consume modules as well. For example, our host main home container, home application, it consumes two routes, two imports from checkout and shop. It's two different bundles. And also it consumes some small widget that we would like to render on the main page. And it's go through the container, to the remote container, and connect using the container external. It's something under the hood of Module Federation, which is cool. We don't care about how it works under the hood. The thing is we just do import and it works. And the same thing with the shared libraries. We just do import of shared library and it works. It's handled by Module Federation as well. So yeah, such a concept that it's a monolith and runtime, but during the software delivery cycle, it's a real micro frontend, which is cool. And right now it's a demo time. So I tried to run some example from the official Module Federation examples repository and try to get access to this private plugin, Next.js plugin, to show you demo. Let me show my VS Code. So here I have a Mon repository with 3 projects. Actually, yeah, 3 projects, 3 micro application: checkout page, home page, and shop page. And also I have some shared directory where I can put any shared libraries, like some custom libraries, some utils, or whatever we need. So, but the thing is, each application is a Next.js project with pages, and we separate Next config. And in this config, I need to add Next Federation plugin that I have access. It's kind of private one right now. And I need to specify the thing that I expose, the modules is exposed, and the important part, my remote modules. So, yeah, so I would like to consume shop module and checkout module from the different micro applications. And if you go to the checkout application and go to the Next.js config, you see that my checkout application, my checkout container expose module checkout, which is separate page. And also it expose title module, which is some widget on the home page. And the same logic with the shop, right? The same logic with the shop, the same configuration, basically. And the structure pretty familiar, like in the usual Next.js application. Yeah, but let's go to the home application. So here you can see pages like we usually create, because the way how Next.js works is check the pages and identify the route. We need to do this hack. We need to use dynamic import, create some separate page, and just load using the dynamic import our model. And the same we need to do actually with the widgets, just to do dynamic import and render it on the page. And let's go to the real demo. So I refresh my page. This is my working example. On the port 3001, I have a server-side rendered page. And if you actually do the preview, we can see that everything comes from the server, which is cool, which is good web performance. But then it actually load all needed stuff for Module Federation to work at runtime. Some pages from the remote, which is running on the different host. I would like to show you, for example, this exposed title is running on the host 3000. It's our checkout application. And as well, I do the same loading chunks for my main application. And also I load libraries such as React and all other global libraries that required on the page using the lazy load, right? Which provide a good performance. And yeah, and everything works on the server side, and get direction on the client side is also works perfect. But when I go to another road, shop road, it's right now client side rendering, and it's return me a chunk from the shop application. As you can see here on the port 3002. And yeah, it's a real micro frontend and everything works fine. But the interesting thing, if I update the page, it will server-side rendering for this page. So it's do the same logic to load some chunks from the different remote containers, but on the server side. And yeah, and as you can see here, the same. Once I come back to this road, libraries and chunks that are already loaded will not be loaded again because of the Module Federation. I mean the global libraries. And yeah, there is our widget, everything works. There is our home page, everything works. And I go to the checkout page. Again, the same logic, the same lazy load to the client side rendering, and even some result from the database, right? Some backend API from the get initial props, but better to use actually get server-side props here. But anyway, it works like the data fetching. And if I update the page, server-side rendering works amazing. And do the same like on the server side, then guide my application. And it's interesting. And I think it's might be the future of micro frontend on the server side. So we'll see how Zach Jackson will finish such a public NPM plugin. And then we will see the future. We see the issues, and maybe it also be following by different organizations, by the community. The few things that I'm not sure about, like can provide a clear answer, have just a few ideas. For example, security. When you do the load chunks on the server side, which is have some server-side logic, it might be some gap in security, but you can do it in your internal network, for example, and use some VPN for local development, or you can encrypt such a data using the public, like asymmetric or symmetric keys, whatever. And another thing is incremental side static generation. I think it might work, but I didn't try it yet. So yeah, interesting concept. Interesting to see the future of such a plugin. So on the client side, rendering Module Federation worked perfect. Is amazing solution, but on the server side, it's something new that I would like to talk about today. And yeah. And basically that's all, guys. Thank you for your time. Thank you for your attention.
Really interesting stuff there. Oh, cool. So you put some stuff
I just sent some links, useful links, and links to my blog and website as well. So if you're interested, you can subscribe. And again, interesting article about Module Federation, but it's mostly on the client side, but it will provide you a bit more context.
Awesome. Yeah, thank you. So if there are no questions, then it might be Shivay's turn to go next.
Yeah. Am I audible?
Yeah,
everyone?
We can hear you. Yeah.
Okay, perfect. Let me just bring up my slides. Let me share my screen. Yeah, is it sharing? Could you just confirm if you're able to?
See...
I'm on my slides page. Yeah, is it visible?
Yep.
Okay, perfect. So yeah, first of all, thank you so much for all these amazing talks, and thank you, Ilesh, for inviting me over for this meetup. I'm really excited for Next.js itself, especially because of the Edge functions and the release of WebAssembly. So I'll be sharing some of my ideas about how serverless and Edge functions, both on the server side, I mean, for the browser and for Next.js, but also how Edge computing itself is really catching up a lot of new really great things, especially in the cloud native space as well. So yeah, without wasting any further time, I'll just get started. So very quick introduction about myself. I'm Shivay. I'm a TensorFlow.js SIG and working group lead. I'm a Wasm Edge ambassador. Wasm Edge is an open source WebAssembly based runtime, and it's mainly used for being able to run WebAssembly applications on the edge. And I'm also a developer relations engineer at Millisearch. So Millisearch is an open source Rust-based search engine. So in case you want to use, let's say, search instead of a static e-commerce website or a documentation website, so it's really easy to just set it up. It's a full text search engine written in Rust. And actually, one of the close relations is that the CEO of Vercel is actually one of the angel investors in our company. So that's a nice one cake. So actually, I'm right now working on a few integrations with Vercel with our Millisearch. So I'll be more than happy to share those once those get released. But yeah, you can connect with me on my Twitter and @howdevelop in case you have any questions from today's session. So today's session, as the heading is we are going to be focusing on serverless and Edge functions. Now, of course, Ilesh and a few of the other presenters did talk a bit about did give a reference to what exactly these are, but I'd like to go a bit more in depth regarding how serverless and Edge functions are set up and what's basically the difference between the two. And at the end of the session, I'd like to just cover that which one should you actually choose, right? Because you are getting both serverless and its functions. So first we'll understand what those are, and in the end we'll kind of see that, okay, which one should you choose for your project in case you're basically building a Next.js project. So the first thing that I'd like to cover is what exactly are serverless functions in the first place, because we hear about serverless technologies and cloud technologies a lot, right? So essentially these serverless functions are basically pieces of the server-side code which run on cloud servers without the actual need of a backend. So typically you would require, let's say, an EC2 instance on AWS or a compute instance on GCP, or if you're using Heroku with a dedicated server, right, where you will host your code and you will use PM2 or some kind of a Nginx server, which will allow you to basically your backend. But the entire benefit of using a serverless architecture is that you don't require a dedicated server, and basically these serverless functions work on demand, that whenever you actually make an API call, they will spin up and they will be able to run. And that makes them being able to basically scale them up and down based on how much traffic you get. It's a little more easier as compared to the standard servers, and since they run on demand as well. But of course, one of the things that you do require some of at least one of the cloud platforms like AWS, Azure, or Vercel in this case for the Vercel serverless functions that we'll be taking today. So you do require a cloud platform where you can actually host these serverless functions. And basically what you'll do is that when you are deploying your application, you'll deploy your service function, and then you can always invoke it whenever you are making an API call. So let's try to understand that how do serverless functions work in Next.js. Now, serverless functions are not directly embedded as part of the Next.js API. They're not directly a part, but what Vercel and Next.js allow you to do is that, of course, a few of the presenters, they covered API routes, right? So I'll just give a very quick glimpse into the API routes again, because that's a very important proponent of how Next.js basically treats these serverless functions. So primarily we are having two different concepts. One is the page route, and the other one is the API route. So for that, I'll just go to one of the sample code base, and over here, you can see that in case whenever you have the pages folder, whenever you create any JS file, let's say about.js or app.js, basically what it's doing is that it's creating an automatic route. So this is the page route, and it's creating the page route, and with that you're basically having a component. So whenever you go to that specific application, so if I run this, you can go to that specific route and it will render the component that you have created. So this is for rendering components. This is the page route. Now the other one is API route, which was basically introduced by Next.js in version V9 of Next.js, and these allow us to basically build and backend application endpoints, leveraging hot reloading, and basically helping us to build a unified build pipeline in this entire process. So all of your API routes exist inside the API folder within the pages directory, and basically while the page route in the Next.js apps, they help to serve web pages, the Next.js API routes are treated as the endpoints. So we'll take a look at how these endpoints can be created, and we basically have support for both static and dynamic API routes. So here is an example of a static API route where I just have a data folder that I've defined over here. It has a list of posts, and this is a static post generation route, right? So it's static API route where I'm just having a get request where I'm fetching all the list of posts, and then I also have one which is a dynamic one, right? So basically the dynamic one over here, where basically what I'll do is that I will be able to I'll basically get the opportunity to go ahead and add I can add a query param where I can provide let's say what's the post ID, and based on that we can get a dedicated response. So this is also known as path segment, where we can basically provide dynamic input and the route, the overall route changes. So the idea is that these API routes are what are converted into the serverless functions, right? So the idea is that we take these API routes, and once we define these API routes, and let's say we deploy our application on Vercel, Vercel automatically detects the API routes or the API folder, the directory, and whatever routes that are there inside of that, that we have created, those are automatically created as serverless functions. And Vercel provides you the ability to create serverless functions, and we can basically maintain logs of to actually view these serverless functions. Now, some of the additional benefits is that you can also create you can basically set up environment variables, and you can send those across with your service functions. And we'll see like an example of this, how this basically functions once we deploy sample application. And I have also created a dedicated example that showcases the serverless capabilities, and how you can also test out your deployed APIs onto, let's say, something like a Postman instance. So I'll share example of basically all of that. But this is essentially the idea that what serverless functions allow you to basically do. So you take your API routes and you can directly deploy your service functions by these. And you can deploy, and you can basically, on the Vercel settings, you can change which particular region you want these serverless functions to be, because since these are cloud hosted serverless functions, you can choose whatever is the nearest center, or basically your what is the nearest region to your wherever you have hosted your application, or wherever you live, for the fastest performance possible. So yeah, with that, let's basically go ahead and take a look at a serverless function demo. So first, I'll just go ahead and share this example itself, because this is the basic example. So if I just run this application locally right now, and just let me go ahead and run this. So I'll just go ahead and run this on localhost post 3000. Of course, this is the sample post, and I can show you that okay, we are having the page route over here, right? So we have the page route, and then okay, so let me yeah, so let's basically take an example of a API, right? So we can go to API/posts. So let's say if I do API, right, /posts, you can see the list of all the this one's some issue with, oh okay, actually there's some issue. I'll just take a look at this. But basically the idea is that and I do have a deployed version of this, so let me also show that to you. I'll just go ahead and show this serverless function demonstration. So this is basically deployed on serverless function. So over here, this is like the demonstration, and I'll also quickly show you how you can monitor your serverless functions that are basically running, and how you can monitor the logs for your serverless functions on the Vercel. So basically, whenever you want to actually create a serverless function, it's very simple. The only thing that you have to do is you just have to use the Vercel CLI. So in case you haven't done that, I'll just first navigate to my serverless function repository. And over here, basically what you just have to do is if you just click on Vercel, you can very simply go ahead and deploy your application. So in this case, I've already deployed it, so it's just building it. So if you had to rebuild it, you can do that. And very easily, what will happen is that once you have created your next application, you just create Vercel, and it will just ask you for a few things related to the configuration, and you will be able to build your application very quickly, and it will get deployed on Vercel. So let's just wait for a second for it to get deployed. So as you can see, it has been deployed now. And what we can do is that we can basically go to our deployments, and I'll first just go to our the existing deployments that I had just done a few hours back. Now over here, you'll see the section for the functions. So this is where basically you can see all the serverless functions that we have. So you can see that I basically have 3 different type of functions, and these are defined inside of my API routes. We have the hello.js, which basically just renders the the Zondo, this simple API routes, and then I have created this one post one, and then the segment one where we can provide a dynamic input. So these are the 3 inputs, and I can basically take a look at any one of them and see the real-time logs. And you can see that by default, the region that I have for this particular one is Washington DC, and the runtime is the Node.js. Of course, now Vercel allows you to basically write serverless functions in multiple languages. So the example that we saw was basically Node.js, but you can write in Golang, Rust, PHP. So there are multiple languages that you can basically write your serverless functions in. It's not just limited to JavaScript. So if I were just to test this out very quickly, let me just go to the specific route. Let me check why it's not coming up. Okay. So here I have like, the posts, and if I just provide like the post, you can see that these are the list of all the posts. Now, if I use the same endpoint inside of my deployed application as well. So let me go ahead and do that. So if I just use the post one, you can see like it works. And now if I take a look at my post, it should basically show the current log of my because I have so it will show you all the latest logs, and in case there are any errors that come up inside of your application, that will also basically come up over here. So serverless functions are, again, like if you're running them in production, they will come up with a cost. So depending on how much usage you get, of course, right now I'm using the free trial version of that, but for some reason, it's not coming up with the log, but it should ideally show up. But we can take a look at, depending on how many service functions we have, we can check the logs of each and every service function that we have. And this way, it's so easy to just go ahead and deploy a service function. Now, what you can also do is that you can change the location of your service functions. So for that, you can go to your versus settings and go to the service functions and basically change where exactly the region, which region do you want to choose. So currently I'm based in New Delhi, so I can, let's say, choose Mumbai, because that's the nearest region to me. So once you've done that, then it will update the service function region, and it will host your dedicated service function in that particular region. So whenever you invoke it, it will be faster in terms of the bandwidth, because the region is closer to you. So we can go back to our deployments and probably, actually add the newer deployment. So let's just take a look at this one, and let's try out with this particular one. Probably this should work, as taking a look at one of the older ones. So probably this should actually appear. Probably some issue, but ideally what you would see is you'll basically see some logs over here. For some reason, it's not showing up. But ideally what will happen is that whenever I make this API call, it will show you real-time logs when you're basically making. So this can be used to just monitor how many how many instances of, or how many times people are basically accessing your service function. So that's a quick demonstration of how it basically looks. Now I also created a full-fledged example, and that example is basically a country flag. So I'll basically go back to my Vercel functions over here, and I'll go basically to my country flag demonstration. So basically I created this application where I'm able to basically see any country flag, specific country flag. So let's say if I want to take a look at country flag of United Kingdom. So I basically have a number of different APIs again. So I'll just go ahead and use the API. Now, as an example, right, I can take let's say Portugal. So over here, what I'm doing is that I'm just rendering I'm giving a query param of any country, and that will render the country flag of that specific country. So let's say if I put India, it will render it for India. If I put probably United Kingdom, right, or let's say Ghana, it will just do that. So the idea is that, and I'll just quickly demonstrate the code base as well. So this is the code base, and the specific endpoint that we are currently using is the country flag by country name. So that's basically this one, that we are basically fetching the get country flag by country name. So we here, as you can see, that what we're doing is that we have just used a npm module for fetching all the list of country flag SVG images, and that's what we are basically rendering on our response. And inside of the request param, we are sending the name of the country, and based on that, we basically fetch the image of that particular country, and we go ahead and showcase that on the response. And similarly, I've just created like number of different other types. So if you want to do it based on the nationality name, or if you want to basically do that like based on the country name, right? So we can probably take a look at let's say the country, get country by nationality as well. So we'll use get country by nationality. And over here, the query param that we'll be giving is going to be like the let me add some. Yeah, so basically the query param that we'll be giving is again like and let me bring over here. Yeah, so over here what we are passing on is like the nationality, that what should be the nationality. So I can provide, let's say, the nationality as let's say Indian. So it will be able to fetch that. So oh, saying this one is missing. Let me just quickly check. But I hope like you get the idea that how basically it is able to fetch the list, right? So basically based on, you can essentially have multiple like multiple functions. And if we go and take a look at the Vercel deployment, if I take a look at specifically at the analytics, the deployment for this, and take a look at the functions over here, you can see that these are the list of all the functions. So basically the one that I initially used was the get country flagged by country name. So you can see the list of all these serverless functions that have been deployed. Of course, again, all of these examples are in Node.js, specifically JavaScript, but the Vercel serverless functions, and I'll just quickly go to the serverless function docs. Let me just quickly go ahead and showcase that. So basically, we are like we basically get multiple languages that are supported. So you get support for Node.js, Go, Python, Ruby. So you can define your service function inside of any of these particular like languages, and you can set up your service function. So that also basically gives you a language agnostic way of being able to select which particular, like in what language you want to write your service function, and that will basically allow you to like very easily deploy this onto Vercel and use it inside of your application, and without having to worry too much about like basically without having to worry specifically about that whether it works correctly or not. So yeah, I mean, this is like an example of the serverless function. And in case you want to like take a look at this code, I'll be more than happy to also share this code with all of you. But that should basically give you an idea. And again, the way of deploying this is very simple. Just go ahead and like deploy it using the Vercel command. So you can install the npm package for Vercel CLI, and you just authenticate to your Vercel CLI, and very easily you can deploy. We can probably take an example of a new project. What I'll do is I'll go ahead and let's say clone this particular project. Let me actually do that. I'll just make a duplicate version of this, and I'll try to do that right now. So what I'll do is I'll go back, and I'll just ensure that I basically delete. What I'll do is I'll just go ahead and ensure that I delete this particular file. So let me just open up a new window and select select one of these. So let me open this up, and I'll just go ahead and ensure to delete the .vercel folder. I think now it should work. So I'll just go to the country copy. And now we can basically go ahead and use Vercel. So now, as you can see, like, if you want to deploy this, so we can select yes, and then I'll deploy it for my personal account. And then if I want to link it to an existing project, in case you have a GitHub project, you can do that. And then let's say I'll give it the name of I am Meetup demo tag, and I will take a look at the directory. So of course it's in my root directory. Okay, my bad. So project name, oh my bad. So I'll try it again, and I'll do yes, and for this particular account. So let's just give it the country flag copy name and root directory. So it will go ahead and set up, and of course for if you want to change the project settings, you can do that. Otherwise, for now, I'll just choose not to modify because I'm just using the default one. So now it starts to build, and very soon we'll be able to see it functioning. And again, what will happen is that right now what's happening is that as the Vercel, it's deploying this particular project, it's taking a look at all the different APIs that are there inside the APIs folder, and it's creating the serverless functions for each one of them. And once the build is successfully done, we'll be able to go ahead and see that live. So let's just probably wait a couple of seconds for it to go ahead and deploy. It's building right now. And I think it should be completing any minute. Yeah, so it's deployed. So let's probably go ahead and check this out. And what we can do is that, we can go ahead and just use this particular where it was. Let me just bring it up. Okay, let me just bring up the URL once. So let's say that I want to use the nationality API. So I'll go ahead and do that. As you can see, now I'm sending the nationality. Let's say if I say Kenyan, probably I'm not sure if this should work. Yeah, so it did actually work. So you can see, right, that now what's happening is that I have used a separate endpoint. Now, a great thing is that I can basically also test this out on Postman. So let me open up my Postman and show you. So I'll basically go ahead and put that as a post request. And in my body, I'll use raw, and I'll define, or basically I can also do JSON. And over here, let's go ahead and define the nationality. Okay. And let's define it as Indian. So let's basically do this. Just give it a double quote. Let's see if this works. Okay, so it didn't. Okay, so for some reason it rendered a error. Let's see. Let me just check. Let's just try some other one. For some reason it's throwing a double error. Let me just double check what could be the reason. Get, and then nationality, then this appears to be fine. Let me just double check why it's throwing an error. This is a real-time issue. Probably let me take an example of probably we can try with the country name. So let me try to do that. So I'll probably use this particular one, and instead of this, I'll say I'll give the country name and give, let's say, India. So this time it basically works. So you can see that the response that I get is for the image from India. And if I let's see what's the URL response that I get. So if I run this, you can see it's the flag of India. So that's what gets rendered. Now, of course, if you also want to basically render this, I already have a working example over here, and it's basically this one. So over here I can give this is the first example. So I can say let's say India, and it will also actually render the actual result of the image as the response. So this is another example of how you can see that these are basically your deployed endpoints, right? Otherwise you would have required a dedicated backend server to be able to do this, but it's automatically taking place for you with the help of the Vercel serverless functions, and it works very well, especially with Next.js. So that's a quick introduction about these serverless functions. Now we'll basically move to our next part, and that's basically the edge functions. So basically the edge functions are somewhat similar to the serverless functions as well. Again, the main idea is that you don't require a dedicated server, but of course there are some important differences when it comes to the service functions and the edge functions. So the edge functions allow basically you to deliver the content on with more dedicated speed and personalization, and these are basically deployed globally onto the Vercel's edge network. And these edge functions basically use the Vercel edge runtime, which is built on top of V8 and WebAssembly. And if you're not aware of like WebAssembly, so WebAssembly is basically like, it's not like a programming language per se, but it's like, very similar to how machine code looks like. So it's a popular compilation target for a lot of high performant programming languages like Rust, C++. And you can basically use these inside of your web applications and even server-side applications because they have a very small blueprint and they're very performant. So they do overcome some of the limitations of like, the of JavaScript itself. So basically the idea is that within a small like, footprint, they provide a lot of performance. So basically what we are doing is that the edge functions, they take advantage of the Vercel edge runtime, and this allows you to basically like, have very quick boot up of your application. It supports caching on the go, right? And basically as compared to serverless functions, you have much more like, higher scalability, and it's much more quicker to actually boot up as compared to a serverless function. Now the fundamental idea is that how edge functions basically work is, and we'll just take a look at this particular architecture, right? So this is basically the Vercel architecture. So over here you can see that basically the initial one is the browser in which the user will interact. Then we have the edge middleware. So basically the edge middleware within Vercel is essentially a code that executes before a request is processed on the website, that is on the browser. And based on the request, you can basically modify your response. That is why you see things like, the redirects, headers that are responsible for your request and response headers, right? And basically the idea is that with the help of these this middleware, you can provide personalization to your static generated content that is appearing on your static generation website, right? With the help of Next.js. And again, depending on the incoming logic, you can either have static logic, you can also basically customize your logic. And the idea is that this middleware is actually what is using the Vercel edge runtime. That's look like that is spoke about how internally, like, these edge functions basically work. And the idea is that within, like, the functions, like the edge functions, in comparison to your serverless functions, the serverless functions basically just like, are always running at a dedicated region, right? So you have to basically define which particular region it should run on. But the benefit of using the edge functions is that these edge functions are very dynamic in nature. So depending on your location, it will basically just spin up whatever is the closest region to you, and the edge function will spin up over there and run over there. So this is like, there are two immediate benefits that we see, that in, like, it's not static, first of all, right? So based on your location, it will just spin up whatever is the like, nearest Vercel edge location. And there are multiple, like, over the entire world, there are multiple edge locations, and based dynamically, like, based on your location, it will spin up your edge function over there. And second is like in the blueprint, right? Since it uses the V8 and the edge runtime, right? So it has a much smaller runtime, much smaller blueprint in terms of the cold start to just boot up the function. And of course, it is also secure because of the WebAssembly. So those are some of the benefits, and that's what, like, this basically showcases in terms of the architecture. Now let's just understand, like, a quick example of how to basically create a edge function. Now primarily there are two things over here. So in the first line, right, that you see over here, we are basically importing a helper from the Next server, and which basically extends the native response object. And the next most important thing that you'll see over here is that, like, basically in the export const config, where we have defined the runtime. So basically edge is still in a beta version right now. The edge functions are not like not in a very production, but you can still use them in production, but they're still in a beta stage right now. So you might experience some, like, errors, because edge functions were released just recently, like, probably a year back. So they're still in an experimental stage, beta stage right now. So what we are doing is that we are basically specifying the functions runtime with the exported config object, and the runtime that we have defined is the experimental edge. And this is basically required to create an edge function. So this is, like, dedicated requirement that we need. And basically because this function is using the edge runtime, right? Since it's using the edge runtime, like, it will basically use the edge middleware as well. So this is like how you basically create an edge function, and we'll see a quick demonstration also how you can do that. Now outside of just creating the function itself, we do also get these edge function APIs, and the idea is that since the edge function uses the edge runtime, it allows you to basically execute any standard web standard API such as fetch event or fetch APIs, response and request, and basically these native web API objects are extended so that you can get control over and how you can configure your request and response based on an incoming request. So that's the idea. About how you can also have dedicated APIs that you get with your browser, specifically if you're using the V8, you can get those native APIs, and those are supported with whenever you're let's say creating an edge function. So of course we'll come back to the last slide at the end, towards the end. But now basically let's take a look at that how you can set up a service function. So basically an edge function. So over here I have an example where again just a simple example where and let me bring up that. So yeah, this is the one. So here it's pretty much a similar example that we showed over here, like how to basically create an edge function. So it's a simple a simple example where we are invoking the edge function, and again what you have to do is I'll just quickly go to my terminal, and we can just go ahead and let me go back to basically the edge functions, and I'll just go ahead and deploy it just once again. So I'll just go ahead and do that. But basically the idea is that once you go ahead and deploy this, right, and again you have to just follow the same steps that we did before, right? And yeah, so we'll just wait for it to deploy, but till then I'll just show you the Vercel, right? I'll show you the Vercel dashboard. So let me go back to the Vercel dashboard, and you can see that I've already deployed it over here in the edge functions, over here, like the edge function. And I can go to my deployments section, go to my deployments, and this time let's go to the functions, and you'll see the difference automatically that over here, as soon as I select my API hello, right, you can see that the runtime is the edge runtime. So if I compare it with the other ones that we had, it was basically a language based runtime. So if I take over here this example, you can see the difference between the two different functions that have been deployed. So if you take an example over here, you can see that the runtime is Node.js, and then it has been deployed to a specific region. But in this case, the runtime that we have is the edge runtime. And in this case, the region is global because there's no dedicated region that we have in case of a edge function, right? So with the help of an edge function, whatever is the nearest location, right, edge location from where you're invoking or making an API call, it will invoke that function from that location. So that's a quick understanding of how these edge functions work. Now we do have some examples of being able to basically run edge functions with the help of WebAssembly as well. So on the actual Vercel GitHub repository, you will find the edge functions, and here they have basically shared a number of them. But the one that I wanted to personally show all of you was dedicatedly towards the WebAssembly side. So basically what Vercel recently announced was that we can basically run WebAssembly modules inside of edge functions. So what essentially that allows you to do is that you can take, let's say, a high performant function such as like a Rust function or a Go function, and basically convert it into a WebAssembly bytecode, like a .wasm file, and then just instantiate that inside of your edge function and use that. And that gives you more additional benefits. So let me go to the edge function definition over here, and you can see under the WebAssembly section, what you can do is that you simply just have to go ahead and do that. And here is an example of the Zor, where basically what they've done is that we basically take Rust like an example, and I'll just go over there. So over here there is a Rust file right inside the source folder. So this is the Rust function that does Zor operation. Now this gets converted into WebAssembly bytecode, like WebAssembly executable. Then you can basically import it inside of your function. So if we take a look at like the actual API and take a look at over here, so you can see that we are basically importing our WASM function over here. And then what you can do is that you can instantiate it and actually use it. So there's also really a great blog post that showcases the performance benefits of actually using WebAssembly. And recently there's also this announcement of the OG image generation. So you might see being able to generate social cards with the help of GitHub does that. And whenever you are say sharing something on Twitter, it generates the like a dynamic image, right? And that's basically known as the open graph image. So with the help of the serverless function, with the help of the edge function, you can very easily go ahead and implement and create these OG image examples, right? So here's basically an entire demonstration on how you basically go ahead and do that. So that's some of the benefits that we basically get with the help of the edge functions. So I mean, of course, the biggest question now is that which one to basically choose. Should you choose should you go ahead and choose the edge function, or should you choose the service function? So ideally, I mean, if we look at it from a high level, both serverless functions and edge functions are doing the same thing, right? They're helping us to not have dedicated hardware, dedicated servers, and they allow you to basically set up your functions directly on Vercel and allow you to run them. But there are some slight differences, especially in terms of the infrastructure. So as I already mentioned that before, that service functions are run from a default selected region, whereas the edge functions run from the entire edge network. So wherever the region that is closest to you. And also because of the fact that these edge functions use the V8 engine that also is built on top of standard JavaScript and WebAssembly, it has a much smaller blueprint, right? So it has faster runtime, faster boot up speed, and also it's much more compact as compared to, let's say, being able to run serverless functions. So especially if you're having if you're it could be possible that you might be having a Next.js application that is, let's say, running on an actual IoT based application, like an IoT based device or an Arduino device. If you're, let's say, hosting your website on that. So because of the resource constraints, because of the resource limitations, you can use, let's say, a edge function that will provide you more lower latency and quicker boot up for your for your functions. But there are some disadvantages that are there with, or basically not disadvantages, I'll call it limitations with edge functions. So at this moment, Node.js APIs are not supported with edge functions, and there's also no support for dynamic code execution within edge functions, because that results in a runtime error, whereas you have the ability to have dynamic code execution within the service functions, right? So those are some of the the differences and the limitations that are still there. Just remember that edge functions are still in their beta phase, right? They're not completely in production ready stage, so you might see some issues, but it's in a very right direction in terms of how Vercel has basically set it up. Service functions are very very powerful as well, and they have been there for a long time, so you can very easily use them. But edge functions for dedicated applications like setting up images, and especially if you are involving if I would recommend, if you were to ask my recommendation, if you require a lot of caching of your data, then use edge functions, because they have better caching, right? So the idea that how basically the edge functions basically work is based on the fact that how you basically use them is that the edge functions run after the cache, after the caching has been done, that's when the edge functions run. So basically, you can have both the cached response or the actual return response that you want. So in case you do require a lot of caching of your data, then edge functions are better, as probably in terms of a number of use cases in terms of the service functions. But yeah, I mean, those are some of the differences between the serverless and the edge functions. But yeah, I mean, with that basically brings an end to my presentation, and I'll be more than happy to take up any questions now.
Oh, that's great. Are there any questions for Shivay?
Yeah, I have some question. First of all, thank you for your amazing, nicely done presentation. And yeah, the question is, first of all, I see this. It's quite a nice solution. It's easy to manage such a function and deploy it in a couple seconds to the Vercel, and amazing dashboard as well. But maybe other benefits or you can share other information if you compare it from, for instance, with AWS functions or something else, something similar to it.
Yeah. So I mean, like in the AWS world, you have the lambdas, right? You have the lambda function, and then Netlify also has their own service function, right? So specifically, if you're having a Next.js project, right, then of course the number one benefit that you get is that it's because of its close, proximity with how Vercel and Next, since it's a creator of the Next.js framework. So probably the Next.js it works best with Vercel. I have tried to very extensively use AWS Lambda functions, and also actually to deploy, let's say, a Vercel, a Next.js application with I think what is called AWS Cloud Front. I think that's what they use for like front end application. Yeah. So especially in terms of but this is more on the side of server side, static side rendering. There's more benefit to using Vercel as compared to AWS Lambda functions. And again, finally, what it comes down to is you also need to take a look at in the language supported, right? So the language is support. You have to compare between them. And secondly, is the pricing as well, right? So obviously, AWS probably has a larger regions at this point of time as compared to to Vercel. But what I've seen is that because I've used both the Lambda functions and also Vercel functions were cheaper for me because again, that could be the optimization that we get with Vercel, that it was just cheaper for me. For the same number of requests that were being made, we migrated our from Lambda function, we migrated for the company that I work with, Millisearch, we migrated to Vercel, and our costs basically came up to be cheaper. So it's probably more optimized as well in terms of and I think the underlying architecture of being able to set up environment variables, and how basically Vercel very easily handles cores, and how very easily can set up cores and your environment variables with these service functions, that it's a very big pain, especially when you're using AWS Lambda functions, because you have to dedicatedly you have to dedicatedly provide your environment variables. But in terms of setting up your Vercel environment variables, it's very easy to just do that. You don't have to manually set up your environment variables. So that's also, I think, one of the additional benefits that we get in comparison to, let's say, the AWS Lambda function.
Nice, thank you for your answer. I just following my previous presentation, I was thinking it's also another benefit. We'll see what will be what will the future of this federated concept. But imagine use federation on the front end and edge and serviceless function on the kind of backend. You can have fully autonomous full stack team as well. It sounds really cool. Yeah.
Okay, great. I guess there's no other questions. So thank you, Shivay. Really good presentation, and thank you pretty much everyone who presented. Thank you. It's been great and very informative. And thank you for bearing with us. Obviously, we've gone a little bit over as well, which is great. Yeah, I just want to probably tell the audience that we'll probably try and get the slides off the people that spoke, so we can share them and share their details after the session. And obviously this will be recorded, so it'll be available after it's been sort of put up on YouTube. I just want to thank everyone, and don't forget, you still get a chance to win the merchandise if you want to. I can send the link in the chat in a minute. But yeah, that's great. Yeah, thank you, everyone.
Thank you. Thank you, Ilesh.
Thank you. Bye.
Thanks, guys. Thanks, Ilesh.
Bye.